And really the key for us and our position in this marketplace is one of doing all that in an open and a COTS way, because that's really where the savings from a cost standpoint are going to come from, and the ability to accelerate time to market and hopefully get there first. So let's take a look at what we'll call a carrier-grade application-ready platform looks like. The carrier-grade application-ready platform really reflects a pre-integrated hardware and software platform that sits below your application and delivers high availability for the particular mobile video app that you're producing, at the same time providing platform independence and application portability. So looking at the diagram here, central to this is the carrier-grade application-ready platform is the high availability middleware that sits in the middle, such as that provided by Go-Ahead. Our product happens to be called Sapphire. And given the importance of standards, it's important to note that a number of the HA middleware solutions in the marketplace, including ours, are in fact based on standards from the SA Forum that Brian just mentioned. For those of you who may not be familiar with the SA Forum, it's a consortium that develops open specifications for the carrier-grade systems, with members including Alcatel-Lucent, Ericsson, HP, Sun, Oracle, Montevista, Wind River, really a who's who of who's in the industry. What's important to understand about the SA Forum specification is really that there are two key specifications. The first is between the application and the middleware, and that AIS specification, or Application Interface Specification, standardizes the interface between the SA Forum compliant middleware and the application itself. This ultimately ensures that the application can be portable across different middleware solutions, and in fact then doesn't lock an equipment provider into a specific middleware application. On the southbound side, the other interface is HPI, Hardware Platform Interface. That in essence abstracts the hardware from the HA middleware and makes each independent of the other. And since most of the carrier-grade hardware solutions in the market today are built to the HPI standard, the specification ultimately shortens the overall development cycle and gives equipment providers the ability to change hardware platforms as technology advances occur. As I mentioned a moment ago, achieving the 5 nines availability really requires that all components of the system be HA enabled, the application, the cluster itself, and the hardware. I'm going to talk about each of those in a little bit more detail. So you can see in my upper right-hand corner, I've got my carrier-grade system, starting to talk about applications. The Availability Management Framework, also known as AMF, is really the SA Forum and Go-Ahead vehicle for modeling the distributed redundant applications. The heart of the AMF, or Availability Management Framework, is in essence the system model, and that's the green disc there shown in the center of that yellow box. The system model in essence describes the redundancy relationships for the application services. Redundancy relationships run the gamut from very simple, 1 plus 1, 2n, to much more complex, where you have n-way or n plus 1 or n plus 1, n plus m. The system model is also the place where we define some of those deterministic automated recovery and repair policies that I alluded to previously that govern the system in the event of a failure. So, for example, in the event of a process failure, very simply restart those processes that are dependent on the failing process. So as you can think about it, that system model is where the definition of how the system should operate resides. Once that system model has been defined and populated, again, specific to your unique requirements, the system model rules are then instantiated into the application itself through the AIS APIs. Here, for example, we see two different applications, one in a 2N environment where I've got an active and a standby, represented by ANS, and then an N plus M environment where I have two active applications with one standby. When we've instantiated those applications, then we can start to look at heartbeating those applications and start to have an understanding of when a problem might occur in the environment. So that's the application perspective that we want to bring to the table. The second area is really to look at the cluster. And at this level, we're modeling the cluster, which is made up of cluster nodes. I think the simplest way to think about this is just that these are the components that make up a network element for you. But it's important to manage them, again, as a single entity. And in this environment, a cluster can consist of the same or heterogeneous devices, such as a chassis, rack mount server, pizza box, as long as each has access to the same redundant IP subnet. Here, there are two examples of what a cluster might look like, much flexibility with our software to define it as you need. On the left-hand side, we've got a cluster that's made up of a single chassis and other computers. And on the right-hand side, you'll see a cluster that's made up of multiple chassis and multiple computers, again, defined as required by your particular subsystem. All right, applications, clusters nodes, let's talk about the third key element to manage from a high availability standpoint, that being the hardware. Now, this is a bit of a complex looking chart, but it really is a very simple concept. Through platform management, which we're talking about here, we model the hardware so that we have visibility to it and dependencies on it for the software. In essence, in this model, we're deconstructing the physical world on the left and turning it into a logical model which we can understand on the right and understand dependencies. Those dependencies may be very simple containment relationships. The carrier blades plug into the chassis, AMCs are plugged into the carrier blades. There's a container concept there. Or depends on relationships where I have two compute blades on my right-hand side of my diagram that are dependent on a particular fan. Failure of that fan would likely indicate a failure in the future of those compute blades. But we want to make sure that we model and understand all the dependencies and interrelationships between the hardware, how they impact one another, and ultimately how they impact the processes in this environment. Looking at each layer is fine. Ultimately, we have to bring it back to the system whole, though. And now I want to look at the context of that automated fault management cycle that I talked about on my first slide. And perhaps just talk you through how this is going to operate with our middleware and other middleware in the space in detecting and managing a fault. So as I mentioned, the first element of the automated fault management cycle is that fault detection. Number of different sample use cases that you see there. Let's take a fairly simple one. Let's assume that we have a 2N redundancy configuration. That just means we have an active and a standby, and that we lose the heartbeat on that active process. So now we have an event, we have a fault that we need to respond to. Moving to the right around my circle, then we need to isolate what's happening there. Given the policies that we've established through the HA middleware, we need to now understand how much of the system is suspect given that the process failed. Our policy says that all the components in the service unit, which is really just a collection of cooperating processes on the same nodes, are now suspect, and we need to act on all of those. For recovery, our policies talk about in a 2N redundancy model, as you'd expect, we fail from the active to standby. And here we're not failing the node, mind you, simply the software processes that have exhibited the failing behavior. Repair ultimately is an optional phase, but likely we want to do this to bring the corrupted resources back online. So the previous active is restarted and becomes the standby for the new active, and then that returns us to a healthy state. Many, many different sorts of environments that you could define here. That was just one example of how the fault management cycle can be modeled inside of the HA middleware. So this has been a bit of a technology dive on what the capabilities look like and can provide. Ultimately, it comes back to the business, though, and my perspective on that is if we look at traditional commercialization cycles where we've got platform design and revenue generating services, which is really the development of the application that's bringing your organization's smarts to the market, system integration and QA field trials, and then ultimately out to generally commercially available product. That process, as we've seen in the marketplace, is typically a 3 to 4 year process from inception to general availability. The impact of COTS and pre-integration is really to drive a lot of time out of the equation, where from a platform design standpoint, if you're adopting an integrated COTS model, hardware and software, the platform design is really bought off the shelf. You then focus your time on revenue-generating services, and even in that environment, the system integration and QA time is much shorter because you've got less that's new that you need to QA. So ultimately what we see in the marketplace is a reduction from 3 to 4 years, down to a model that really is a year to a year and a half, at the outset 2 years, but taking that time to market and making it much, much quicker than you can achieve by doing it on your own. So that'll give you a sense of what we talk about when we talk about system reliability in this space. Another key element of the carrier-grade 4G mobile video app is the quality of service. With that, I'm going to turn it over to Brian Wood from Continuous to talk about his perspective on that topic.
Great. Thank you, Bill. So Brian Partridge gave us a market-level view, kind of a high level of 4G and video and the projected traffic demands of that. And then, of course, Bill has just given us the platform or the system-level view, kind of a deep dive into the actual infrastructure. So what I'm going to do here in the next few slides is bridge the gap between those two and talk about the network-level view of delivering carrier-grade 4G mobile video. So clearly there is huge demand for video. I don't think there's any question about that. Like Brian said, increasing 130%